Today we're going to begin our discussion of elements. Some things you may not have thought about with elements. Well, first of all, there are 116 known elements. 88 occur naturally. 9 elements account for most of the compounds on the Earth's surface. What you see here is sand. Sand is silicon dioxide, and silicon and oxygen are two of the most abundant elements. Almost half the mass of the Earth is accounted for by just oxygen. So the distribution or mass percent of the most 18 abundant elements on the Earth are listed. So number 1, we have oxygen. Oxygen is almost 50%, it's 49.2. Next we have silicon, which is found in sand and rocks. Next we have aluminum. And after that we have iron at 4.71%. And then we have calcium at 3.39%. Then sodium at 2.63%. Then potassium at 2.40%, magnesium at 1.93%, and hydrogen at 0.87%. Now the other elements are listed in order of decreasing percentage of abundance. So next we have titanium, chlorine, phosphorus, manganese, carbon, sulfur, barium, nitrogen, fluorine. And all others account for 0.49%. Now the abundance of elements in the human body is much different. Oxygen we see is the highest one. So oxygen is number 1 at 75%. So we have oxygen pulling in the number 1 spot. Number 2 spot we have carbon at 18%. Number 3 spot we have hydrogen at 10%. Number 4 spot we have nitrogen at 3%. And then we have calcium, which makes up our bones and our teeth, at 1.4%. Then we have phosphorus at 1%. And then at less than 1%, the elements are listed in order of decreasing abundance. And then we have magnesium, potassium, sulfur, sodium, chlorine, iron, zinc, arsenic, chromium, cobalt, copper, fluorine, iodine, manganese, molybdenum, nickel, selenium, silicon, and vanadium. All those are in the human body. Here's some nice visuals I found. This is one showing the abundance of of elements in the Earth's crust. You see oxygen at the number one spot, silicon at number 2. Then we see a nice visual. Here we have the aluminum at the number 3 spot. And then here we have iron at the number 4 spot. Iron is actually in a lot of rocks and different minerals. Then after that we have calcium, sodium, potassium, magnesium, hydrogen, chlorine, and then all the others. That's on the Earth's crust. Here's another visual of the same one comparing the Earth's crust to the human body. We see Earth's crust, once again, oxygen, silicon, and then other is sort of a big category. We have aluminum, then iron, then calcium, then the other ones are in that category at 9.2%. Human body, we have number 1 still oxygen, then carbon, then hydrogen, then all the other ones fall in after that. So 2 comparisons of the Earth's crust and the human body and the elements that make them up. Now here's another one comparing the universe. Now we see the universe much different. We have a high abundance of hydrogen. So hydrogen is number 1 in the universe, then helium. Then next we have oxygen. And then all others are 1%. Notice how different that is from humans, which are oxygen, then carbon, then hydrogen, then nitrogen. Now here's the comparison of the sun and the stars, where the size of the circle, which is logarithmic, represents the elemental abundances. So we see hydrogen and helium are very high, then all the other elements sort of fall in after that. Now, when we talk about these elements, some of them, the names seem obvious or the symbols look very different. Now, why are these symbols so different? So here are some original names that we can look at. For example, for antimony, that's SB. Stibium was the original name for antimony. Now we know copper has abbreviation Cu. Well, its original name was cuprum. Then iron, which is Fe, was ferrum. Lead was plumbum. And then we see mercury was very different. There's mercury, which is Hg. Then we have potassium was calcium. Silver was argentinum. Sodium was natrium. And then tin was stanium. And tungsten was wolfram. Those are some original names of some elements. Natural state of elements, one thing I want to mention is the diatomic elements. It's very important you remember these: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Now notice the gases. The ones that are listed first here are gases. So these are gases. Then bromine here is a liquid, and then iodine is a solid. Now, one way to remember those is to remember Brinkelhoff, another is to remember their location in the periodic table. They also make a number 7, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then throw in hydrogen. That gives us our 7 diatomic elements. That is a diatomic element. That's bromine, which is a gas. It's a colored gas. There's other diatomic elements such as nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. That's our 7 diatomic elements. Now, these elements that are diatomic, some of these are very common and they're part of our air. So, for example, hydrogen, nitrogen, and oxygen. But two we want to be wary of are poisonous gases. Those are chlorine and fluorine gases. Fluorine is a pale yellow gas. Chlorine is a pale green gas. Now we saw that was a bromine. Now bromine is a reddish brown liquid, but it easily vaporizes, and that's what we saw on the previous slide. Then iodine is actually a solid. It's very lustrous, which means shiny, and it's a dark purple solid, almost black in color. And one of the last things we want to talk about is when we talk about the natural state of elements, we talk about something being an ionic solid, those atoms are very close together. So we see there that's a sodium atom, which has a positive charge, next to a chlorine atom, which is a negative charge, and they're all packed in there together. Now if we look at a solid metal, all the atoms are exactly the same. They're right there next to each other. Now, but the diatomic elements, those are going to be 2 atoms bonded together, and those that are gases are going to be fairly widely separated because they're a gas. So that's what we're going to stop. That's just some information about the natural state of elements. I'll see you tomorrow in class.